Now, we've gone over properties of organic substances. We've gone over the hydrocarbons, alkanes, alkenes, alkynes. We've gone over how to make isomers and name them. We've gone over all the functional groups, and this is the final thing for organic chemistry, organic reactions. And we've already done 2 of them, so we're going to start out with the 2 that you already know, and then we'll go into some more. So, Roman numeral 1. Roman numeral 1 is fermentation, and we've already gone over this. You need something that has sugar in it. All right, something like grains, wheat, oat, barley, corn, or grapes, or anything that has sugar in it, and then you can ferment it to make alcohol. Remember, we need this one enzyme called zymase. And from that, we get ethanol or ethyl alcohol, or the common name grain alcohol. 2 molecules of C2H5OH. So that is the main product, that's ethanol. And then we get CO2 gas given off. So that's fermentation, and we've already done it. So simple sugar, that's glucose, a little bit of yeast, zymase, 2 molecules of ethanol, which is the real alcohol, and then CO2, gas given off. All right, that's fermentation. We've already done that. The next one we just did. So if you'll put down Roman numeral 2. Roman numeral 2, and this is esterification. And this is where you take an organic acid and an alcohol. You dehydrate it with an acid. And that is dehydration synthesis, so you take water out and you put the organic acid and the alcohol together to make an ester. Okay, now I'm going to do one on the board, and then we'll move on to the next organic reaction. So, the organic acid we're going to use is this. That is ethanoic acid. Plus pentanol. So, remember how to name these things? Ethanoic acid and pentanol. You take the alcohol, chop it so it's pentyl. And then instead of ethanoic, it's ethanoate. All right, that's how you name them. Remember, the alcohol first, chop it, that's the first part, and then ethanoic, whatever the acid is, you put O8 instead of ic. All right, now we're going to build it. There's my ethanoic acid with the Cu at the end. Remember, organic acids are weak. They don't ionize very much. Now, pentanol has 5 carbons. We're going to put the OH at the beginning. right, so that's what that looks like. So there's 1, 2, 3, 4, 5. So there's 5 carbons, pentanol, there's an OH there. Now, remember dehydration synthesis. So what we're going to do is we're going to take the OH from the acid and the H from the alcohol, and we're going to make H2O there. All right, so that's going to drop down. Now on the other side, we're going to get this. We're going to get CH3CO, CH3C, double bonded O. Now, when I erase what I took out, what I have is I've got that O, and we bond it together like this. So there is the molecule. I'll build it over here. O, and then 5 C's. That's pentyl ethanoate right there. And now the molecular formula. And some of you, when you built the molecular formula, forgot to put the double bonded O up on top. If you forget the double bonded O, it's an ether. And that's not what we're going for. So this whole thing right here, I'm going to write right here. All right, so here we go. We have COO, and then C5H, count them all up, and there's 11. So this is the structural formula for pentyl ethanoate. This is the molecular formula. This is the hardest functional group to do, but this is an organic reaction. Esterification, and don't forget, an ester is just a fat or an oil. All right, an ester is a fat or an oil, and it's the smells of all the flowers, right? Remember the smells of the flowers. So esters are very good smelling. All right, those are 2 organic reactions. Now we are going to do 2 more organic reactions. And we have to do these side by side, and you'll see why in a second. The next organic reaction is called substitution. And the other one is called addition. Now, here's the deal, why we're doing them both simultaneously. Substitution, like if you're at a basketball game and you substitute something, one person comes in, one has to go out. That's substitution. For addition, addition means you just bring something in and add it to what's there already. All right? So that's addition, you add it to what's there already. Substitution, one comes in, one must go out. For substitution, we have to use a specific type of hydrocarbon, and it's called a saturated hydrocarbon. So we have to use a saturated hydrocarbon. All right? Now, the saturated hydrocarbons are the alkanes. So I'm going to put that in parentheses. Now, let's just use, for an example, ethane. So all the black spaces, there should be hydrogens. Oh, I might as well put them in. Now, you can substitute whatever you want into that alkane. Usually, they substitute halogens, fluorine, chlorine, bromine, iodine. So watch. Let's go like this. So what I want to do is I want to substitute the chlorines. So if I put those two chlorines into that alkane, something has to come out. So in other words, I'm substituting. I'm putting in the chlorines, and hydrogens have to be blown out of the structural formula. So what happens here is this. Here are my two products. I would get this. But instead of all the hydrogens, I'd get two chlorines. And then we substituted the two chlorines in, we have to get two hydrogens out. So that is called substitution. Now, the huge thing about substitution is this. Now watch. Saturated. We need saturated hydrocarbons. Saturated starts with an S. Substitution starts with an S. So substitution needs saturated. And it goes substitute. And the 2 in substitution stands for two products. There's one product there, and there's another product there. So substitution, you need saturated hydrocarbons, which are alkanes, and you get two products. So I'm going to put that down for number 3. You always get two products. So that's substitution. One more time. The S stands for saturated hydrocarbons like alkanes. You're going to substitute something in, and if you substitute something in, something must come out. And usually you substitute halogens in, and hydrogens get blown off the hydrocarbon chain. All right, that's substitution. Addition, like we talked about, is you bring something in, but nothing comes out. You're adding it to something already there. So instead of must use a saturated hydrocarbon, for addition, you must use an unsaturated hydrocarbon. So unsaturated hydrocarbons are alkenes and alkynes. So the very first thing for addition is you have to use unsaturated, means double or triple bonds. All right, you got to use the alkenes or the alkynes. That's the first thing. Now, we're going to go to number 2. And we're going to make one. So let's use ethene. So look what we're doing here. I have ethene, that's C2H4, got a double bond in there. I want to put 2 hydrogens in there, but for addition, they go in, nothing comes out. Well, how is that possible, that nothing comes out? Because we're going to break that double bond. Once we break the double bond, we have 2 more sites, and those 2 sites will be occupied by 2 H's. So we have that, and this is the product. So, for addition, you use an unsaturated double or triple bond, and then when we bring in something, when we add it in, we break the bonds, make more room, and there is only 1 product. So substitution, you got 2 products, but addition, you only have 1 product, and that's going to be number 3. So we only have 1 product. So we'll do another one just to see how it works. But that's why we're doing them right next to each other. Substitution uses saturated 2 products. Addition uses unsaturated 1 product. Okay? All right, let's do one more. This will be number 4. This time what we're going to do is we're using an alkyne triple bond. This happens to be ethyne. And we're going to add 2 more hydrogens. Well, it's a triple bond, and once we knock out 1 bond, we have 2 sites. So we don't have to go all the way down to a single bond between the carbons. We only have to blow away 1 bond. So it looks like this. So from triple it went to double. Now we have 2 more sites. So we got that original H, this original H, but then we can put 2 more H's on there. Like that. Okay? That's substitution, and that is addition. They're pretty easy. All right, so those 2 are taken care of. Now, we have had fermentation, Roman numeral 1, esterification, Roman numeral 2, substitution, Roman numeral 3, addition, Roman numeral 4, Roman numeral 5 is oxidation. Now, oxidation just means oxidize. So here's what we're going to do. So we're going to take a hydrocarbon, alkane, alkene, alkyne, whatever, and then we're going to burn it in the presence of oxygen. You need oxygen to burn, and it's called combustion. Okay, combustion. And there's 2 types of combustion. Okay, let's go for letter 1 or letter A. The first type of combustion is called complete combustion. And in our world, there isn't very much complete combustion. Okay, so watch. Here's a formula. Let's use the simplest hydrocarbon, methane. And in complete combustion, there's enough oxygen to combine with the methane to produce just these two products, CO2 and H2O. Just those two products. Okay? That is complete combustion. All right, so let's balance this thing because I don't like to leave things unbalanced. So, let's see what we have. We have 4 hydrogens, so let's put a 2 here. That would give us 4 hydrogens. That would give us 4 oxygens. So all we have to do is just put a 2 here. And I think we're pretty good to go. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. We're good. That is complete combustion. All right? So the next one we're going to do is incomplete combustion. And this complete combustion, like I said, gasoline engines, they're not complete combustion because they got all sorts of carbon monoxide and all sorts of pollutants with them. This complete combustion, forklifts in factories usually use propane, not gasoline. And propane, when you burn that, it almost is complete combustion. But all gasoline engines are the next one, letter B, incomplete combustion. Now, okay, so now incomplete combustion, like I said, is just about every type of engine there is. Ship engine, plane engine, car engine, truck engine, motorcycle, lawnmower, weed whacker, any gasoline-powered engine is going to be incomplete combustion because there's not enough oxygen to make it all CO2 and H2O. So you get this, which is carbon monoxide, and you get this, which is soot. And if you have a candle and you have a sconce, which is a glass container, and the candle's in the glass container, when the black forms around the top of the glass container, that's soot, and that's just a product of incomplete combustion. So for oxidation, we have complete combustion and incomplete combustion. And the way I remember it is, our muscles are burning, okay? They're burning and energy is being produced, and what we exhale is the product. And the 2 products we exhale CO2 and we exhale water vapor, H2O. So that's complete combustion. So I always say people do complete combustion. All right, but any gasoline engine is incomplete combustion. All right, so that takes care of that one.